More questions you guys want to talk about before we dive on in? No. Okay. That is. Oh, that is a. Oh, sure. No worries. I'm not in a big hurry. I just didn't see anyone like handing up, but we're happy to wait. No big deal. $125. Certainly.
Holy crap. That's a heck of a problem.
And what did I do?
Is this in the last heck of a problem. Close to 130. You see 130 above? Are you serious? I actually cheated today, I think. You actually? Yeah, did you ask him? No, Jack said I wanted to pitch. I didn't even know that.
All right. So 125, this is the one, right, Morgs?
Yes.
Okay. So I would start by just kind of thinking about this as a proportion and just do like a cross multiplication thing. That way I can get the variable out of the denominator of the fraction. And then I'll divide by 200. And I'll reduce that as I go and just write that as 5 over 2. Then I have to subtract 1 from both sides. So that's, again, I'll leave it as a fraction, 3 over 2. And then I'll divide both sides by 25. Again, I'm going to leave it as a fraction. And then to get rid of the exponent base e, I'm going to do a natural log. Log base e, so the logarithm matches the exponent base. And then divide by 0.3. And then it's just calculator time, my dudes. Yes.
So if we have a population question where the formula is set up like this, could we just solve it like this too instead of using a calculator?
Absolutely. Yeah, absolutely. So we have negative, negative 9.38. Is that right? Let's look real quick. That felt weird that I got a negative answer on that, but it could be okay. Oh yeah, okay, good. I didn't see anything I did wrong, but I was a little surprised it didn't come out negative, but I guess that's not totally unrealistic. Oh yeah, sure. Yeah, not unrealistic at all. Okay, I'm happy. Morgs, you good? Okay. Lena, did you have one that you want to talk about? Same one. Nice. That was a twofer. Tompkins.
Are we going to be given the rules for logarithms on the quiz final exam?
So the final exam, if you look at on the content library under the junior section, what I give you for the final exam, equation-wise, is right here. So if it's not on this list and you want it, it should go on to your note sheet. Yeah, it's a whole sheet, and it isn't a card. It's like a full-size sheet of paper, front and back. You have at it.
What do we have for the midterm?
I think I gave you a half sheet, front and back. There's more stuff that's like separate, like disparate, I think, this semester than last semester. Last semester, everything was kind of very overlapping.
Yeah.
Joe.
On the home quiz, will we be getting like the equations for the population?
No, but I don't think you'll need it either, really, so to speak. I don't know.
Are we gonna have like a population with question?
Well, I mean, yeah, possibly.
So like, do we need to know the equation?
Probably would help. Christian? 30. Ooh, going in the Wayback Machine for that. That's okay. All right. So it says the population of Las Vegas, Nevada was 478,000 and was increasing at a rate of 6.289% every year. At that rate, what year will the population reach 1 million? So again, general population model. So we're interested in when the population is 1 million. Equals 478,000 is the initial. 6.29, and then to the end because it's asking about what year. So you can either do this graphically, where I just graph the left-hand side and the right-hand side and look for an intersection. That's fine. Or we can do this algebraically at this point. Let's do it that way since we haven't really done that. But now we're super capable of doing that. So I'll start by dividing both sides by 478,000. And I'm going to just reduce that in like just a little bit because it's easy reducing to do, where I just drop 3 zeros off each of them. And then I'm going to turn that into a, combine some like terms there. And now to solve for n, I'm going to do the log of both sides. Which log would I want to use? Nope.
Log of 1.06289.
Yeah, I'd want to use the log. Man. So here's the thing, Christian. It's not wrong to use the natural log or something else, a different log here than what we're using. It's just that you don't get that so neatly if you don't pick the log whose exponent base matches the, or whose log base matches the exponent base, which is like, if you have the choice to do it the easy way or the hard way, like, man, I'm taking the easy way. You know what I'm saying? There's no shortcut home, right?
I don't want to drive.
Did you find it though? Your grind, that is.
No, I don't think you did.
I did. No, without finding my grind out. Okay.
You just be ground into a pulp. Nolan.
So the way I did it was I just put 1 million equals 478,000 times 1.06289 to the x. I just solved it from there. That would be
You just skip a couple steps. It's the same thing.
so I don't need to use that like original equation. I just kind of
It's the same thing, but you went faster.
I'm confused at what you meant, but it's probably okay.
As
yeah.
long as you got the right answer.
I got 12.1. So
Yeah.
So,
So you just kind of guess and checked it then, is what you're saying?
no, I like.
No.
I think I just skipped. No, I just skipped steps.
Oh. Okay. Yeah, that's the gist of it, though. Christian, you happy with what we did there?
yeah.
Again, no big deal. Like the solving's pretty easy. Or you could do it calculator, just like graphically is okay. I think at this step, these problems, that was the assumption that you would do, but some of us were already like, yeah, I remember logs from last year, like, let me just log it. I'd rather do that.
Yeah.
So either is okay. No
Thank
biggie.
you.
Sure, no problem. Last call questions from yous guys. Okay. let's finish up section 1515 then, and close out this year, right, with the last of the content. Whoa, that's loud. Want to pull the door shut while you go? Thanks, dude. Somebody's listening to like their heavy metal next door, huh? I didn't even recognize that band. All right. Actually, before I write this, even let's. What are you offended at, Joe?
Christian made a funny joke. I'm not funny, but
Oh, okay.
Let's go. I know
Let's do that. So last thing we did on whatever that day was last week that we had class, we talked about continuously compounding interest, right? Where we did the little derivation of how we came up with the formula. So that's, again, all I'm doing is just kind of recapping that formula there because it'd been a minute. Let's do an example, though, where we use that, right? So this says Jack invests $800 into savings account with a 5% annual interest rate, compounded continuously. That's the key word there, right? How long will it take for Jack to have $500 in interest? So remember, future value is just present value plus interest. So the future value that we're looking for is 1,300, right? And then we'll just plug her in. Everybody looks good, the setup there? So divide by 800. I'll do some reducing along the way. How am I going to get rid of that exponent base of e?
natural log.
This time it's time for the natural log. And then we'll just multiply both sides by 20. And we're calculator time. My dudes, 20 times natural log 13/8 is 9.7. Everybody feel okay there? So a real practical question in regards to like these finance related questions are we've now seen we have all these different like number of compounds we could have, and we see that it does affect like the future value if we hold everything else the same and then like change the number of compounds. That does have an effect. So one of the big questions we're left with is how do I compare like one interest rate that's compounded weekly to like another interest rate that might be compounded daily or something? Like how can I tell which one would be better? And we'll talk about like what that means here as we do this example, which is kind of the gateway to that idea. So this says we have an account that has a 6.5 annual interest rate, compounded monthly, and we want the equivalent interest rate for an account that's compounded annually. So we'd have the monthly one, and then the annually one. Everybody's okay here? Now, if I kind of look at this, and I treat these like a b in like a general exponential function, these would be the same function, right? If those would be the same b. Everybody agree? that's kind of like a base of an exponential. So all I'm going to do is set those equal to one another. So I'm just going to subtract 1 from both sides and multiply by 100 to get the r by itself. So if I go and I type that through, I get that the 6.5% compounded monthly is equivalent to about a 6.70% compounded annually. So what becomes kind of standard industry practice is if I want to compare two different like investment opportunities that have different terms, like have different interest rates and different compounding periods, what I do is I convert them both to annual interest rates to compare them. We call that value the APY, the annual percentage yield. All that is like, okay, some interest rate at some number of compounds. What is that equivalent to just as an annual interest rate, right? Where it just compounds once per year. So that's the idea. And you'll notice that the equation here for APY, the annual percent yield, is essentially just that solving that we did there, right? We have 1 plus R over 100K to the K minus 1, which is exactly what I have written here, right? Just with numbers in its place. So let's do this as an example. So we have two opportunities. One where things are compounded quarterly, and another where they're compounded weekly. And we're asked to decide which one is best. So all I'm going to do is calculate the APY for both of them. And see which one gives me the higher number, right? So I'm just plugging both of those two into the compound interest formula. And then it's calculator time. Calculator. Calculator. So the first one is 803. And the second one is going to be this number that I'm going to come up with shortly. But I started talking when I still had a lot of typing left to do. So now I'm just kind of jogging in place. 794. So which one would I rather have? Whoa, Boise did something there. That's what happens when you lay your stylus on the mouse pad. Okay. The bigger one, right? That's the takeaway. Okay. Kind of one more idea to talk about and a couple more examples based on that idea. So at this point, really all the investments that we've looked at have been kind of like lump sum investments, right? Where we just make one single investment and then sit and do nothing waiting for it to earn more money. Now, most of us, that's unlike the kind of investing that we would do, right? If you're saving for retirement or for college or whatever, what are you probably going to do? You're going to save a little bit of money every month and put that into an account and let that accrue interest. But you're going to be saving a little at a time, right? So that is called an annuity. And when the amount you save that you invest every period is the same, we call that an ordinary annuity. And that's really the kind of savings most people do. It's like, oh, every month I'm going to put aside $250 from my paycheck and blah, 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 or whatever the number is. So we call that an ordinary annuity. So the future value of that investment is going to be that monthly payment that's going to be the same every month times 1 plus I to the n minus 1 over I, where I is just like the interest rate per compounding period, and n is just the total number of compounding periods. So little I is R over 100K, where R is the interest rate and K is the number of compounds per year. And cap n is just the number of compounds per year times the number of years. So the total number of compounding periods. So let's take a look at an example. So this says at the end of each quarter, Sarah makes a $500 payment into an annuity. If her investment earns 7.88% compounded quarterly, what will the value of Sarah's annuity be in 20 years? So we know that the K is 4, the payment is 500, the interest rate is 788, and the number of years is 20. So we're just looking for a future value. So we're just going to plug those into the formula from above. Everybody feel okay with what we typed in? Now this is going to be a little bit of a booger to type into your calculator. In particular, if you don't have the fraction command on your calculator. So what I like to do is I'm going to take that value for little I, in this case 7.88 over 100 times 4. And I'm going to store that value, so I'm going to use that STO button right above the on into, say, the letter I, because it's the same letter that's in my formula. So I'm going to save that so I can use it later. So I'm going to do then 500, and I'll do that fraction command, 1 plus, and then I can just recall that value for I now to the 4 times 20. Minus 1 over I. And that'll cut down a little bit on the parentheses and the fractions within fractions and makes it a little bit easier to get into your calculator if you use that STO command. So what does she end up with? $95,483.39. That's not right, though. It's $83. $83. There we go. Everybody okay with that? What's another kind of investment situation where we're going to be making regular payments? On a loan, yeah, on a loan. So if you're borrowing money to pay for a car or buy a house or you know, a new pair of shoes or whatever, often these are set up where you're going to make regular payments. So here, if we're borrowing money rather than investing, the annuity formula is going to be a little bit different, but essentially all we're doing is we have an annuity. So the monthly payment, still PMT, and the formula there is a little bit changed, but the I and the cap N still mean the same things. So it's just another little version of this annuity formula that, because instead of it's an investment, you're like paying off a loan, right? All right, so let's look at an example. Maria buys a new car for $18,500. What are the monthly payments for a 4-year loan if she makes $2,000 down payment and the annual interest rate is 2.9%? So let's ask kind of a dumb basic question, but an important one if you've not ever bought anything before. What does it mean by a down payment? Yeah, so the thing costs $18,500, right? The down payment is I'm going to pay $2,000 of that right away. So how much does the thing cost after the down payment? And where am I getting that money from? I'm borrowing it. Everybody's cool with that? So the present value is just going to be the cost minus the down payment. What is the K in this case? It's 12. Okay. So again, I'm going to do the same kind of thing on my calculator. I'm going to take advantage of that STO command. And now I'm going to do just this part that's attached to the payment. Now don't forget your negative sign here in the exponent. Very easy to do that. So there's that. So I have this 16,500 equals payment times 45.26-ish or whatever. So to get the payment by itself, I'm just going to divide 16,500 by that 45 number to get $364.49. Everybody happy with that? Okay. So the big remaining question here, and the last question that I have to ask is how much did Maria end up paying in interest on her loan? How would I figure that out? Well, how much did Maria end up paying on her loan? How would I calculate that? Four. So I'm going to take the monthly payment, right? that I do every month for 4 years. That's how much we ended up paying to the bank, right? How much did we borrow from the bank? $16,500. So what was the interest then? The difference between those two, right? Everybody cool with that? What if I asked how much in total did she pay for the car?
You got that.
Add the down payment to that 17,000 number. So the car ended up costing $19,495 and some pennies because I had to borrow the money to pay for it. What do you guys think? Pretty okay? All right. So I think at this point, your last one, woohoo, is that 131 to 184. Just as a reminder, if you've turned in everything up to this point, there is a dropped homework assignment. So do you need to do this to be able to turn inable? No, it's not going to make any difference in your grade if you've done everything up until this point if you don't turn this one in. Should you still do it? Yeah, but you can just hold your calculator in your hand and be like, I'm just going to do the odds, just going to make sure I can get the answer. I'm not going to write anything down to turn in because I know I get one dropped anyway. So whoop-de-doo-doo, I'm just going to do this for me instead of for Mr. Kulik, which is totally fine. John Paul. Certainly. But that's the gist of it. What do you guys think? You feel good? All right. Let's do this homework quiz that you guys